Okay, yeah. What? Okay. Here we go. What? Okay. Cool. All right. All right, all right, all right. Give me a second here, guys. Okay. Just getting Insta set up. Almost there. Now's the time to get the caffeine and the snacks and all the stuff. Hey, Jonah. Whoa, man, that is small. Okay, there we go. I think my eyes are tired or something. All right, we almost have Insta. Huh. Whoa. Insta's like showing landscape. This is okay. That's I've never seen that before. I, I like it, I think. But it kind of is Huh. Okay. Did I press something different? Hey, Insta people. Can you chat what you're seeing on your screen? Because I'm seeing landscape mode. And but I don't know if it's just showing just one small piece of the screen or if it's actually taking up the whole screen. So holler at me and let us know. Hold on, maybe I'm going to check my phone real quick. Thanks, John. Or Jonah. Let me see here. Give me just a second. Huh. Trying to see me. Hmm. Okay, landscape. 6th gen. 6th gen 6, you're on IG and it's getting the whole screen. Is it like sideways? I mean, that's awesome if it's doing that. I've been wanting to do that for forever, but it just hasn't worked. Because I'm seeing something different on my screen over here than I normally do. Because it usually goes portrait mode, and I'd really like to. For some reason on my phone I can't get to IG. Yeah, it looks good. Okay, it looks good. When I comment, I get the keyboard, then it zooms in. I don't know. Okay. This is different, right, guys? You haven't seen this before? I mean, different for me, anyway. Okay, well, I think we are getting people dialing in. Oh, I guess maybe I should let Discord know. Okay. So today, Twitch chat is not working. Uh-oh. Hold on, let me check. Okay. It's getting some... I'm getting some weird messages. Okay. Thanks for following, guys. Let me check Facebook real quick. We always have these first time issues. We'll look at that in a second. Okay. Yep. Facebook looks good. Yeah. All right. Yeah. Yeah. Syntropex. I was seeing... Hey, Dino. I was saying the same thing earlier. something different is going on with IG. I'm not sure. I mean, I kind of like that it's showing the full thing, but let me just check one more thing. Okay, I've got it in landscape mode, and I can put it back into portrait mode. All right, so IGers, here we go. I'm going to try to put it back in portrait mode. Let's see what happens. This might break everything. Or it might not do anything. I mean, I've had it in landscape mode for a long time. And I think just now it's finally starting to pick it up. Okay, I don't think that did anything. All right, well, I think maybe we'll just leave it. We'll just leave it be for now. And hopefully it's okay for you guys. Holler if it's kind of a pain. And I'll fiddle with it some more. Yeah, we'll just roll with it. Okay, cool. So today we're gonna, I think, mostly just chill. I was super busy with house stuff. A lot of it got sorted this week, and then I'll be moving into my new place next week. So super pumped about that. But I finalized all the stuff with my house sale. That all happened this week. It was just utter madness. Super pumped. And I got the new place all sorted, and I think maybe I might even start moving into it early next week. And once I do, I'll give you guys a tour. Okay? I'll find a way. Maybe I'll use my phone and I'll give you guys a tour of my new house. So you can, yeah, thanks, Dino. I appreciate it. It's been, guys, I gotta be honest. It's been a lot. And having a lot of bills, but the bleeding is almost stopped. So anyway, so given that I didn't have much time to prepare stuff, but there's a couple things I wanted to talk about. In particular, I want to talk about this OpenAI pausing reinforcement learning training. And no, it's doing the double chat thing. Eventually, we're going to fix this. But I want to talk a little bit about OpenAI pausing their reinforcement learning training. And then there's this interesting different paths of OpenAI and Anthropic for this data retention. And it's very interesting. I want to show you guys this. And then I want to, maybe we'll get into some of the machine programming stuff that we didn't get into last week. So I'll just add this. This is machine programming 432. I had it all set, but I think we talked about something else. And then anything else you guys want to talk about. So while we're rallying the troops, feel free to drop in where you're dialing in from. This is always a great start for our chats. And of course, I'm in NorCal. And we start teaching the machine programming course I think about a month from now. And I know some of you are actually even flying in for it, which is pretty freaking awesome. And the details of my class, let me, just for people that don't know, is over here. And so it's only 10 weeks long. Well, it's 11 because there's a break week or something. But 10 actual lectures, pretty long, about 3 hours. I'm going to not actually do 3 hours of lecturing. There'll be breaks and stuff. But it's on Tuesdays, 6 p.m. to 9 p.m. And anybody that is from GDT, if you want to audit the course, all you have to do is tell me. Just email me at goju@stanford.edu, and I'll add you, and you can sit in and learn more about machine programming thingamabobs, all the crazy ideas I have. Jalisco, what's going on, man? Yeah, hold on, let me yell at Claude here. Maybe we'll sit and work through this. It'll be a little cumbersome. You guys can bear with me and this nonsense. This might be just like a super chill live session. Rather than trying to hit things hard, maybe I don't know, maybe we'll kind of do a marathon. So we're here for a while. Haven't done one of those in a while. Okay, let me see if I can get Claude to fix this double output thingamabob. Claude, we're getting the double line output on the chat. We've tried to fix this 200 times. Please fix it properly this time. It's also eating. Thoughts on aux? What's aux? Is this a new family of models? Tennessee. That's awesome. Wait, do we have 2 people from Tennessee? Wow, this is so great. I think 2 people from Tennessee, 2 people from Texas. Okay. It's eating the line separators and stuff too. Fix. By the way, I'm actually getting some aux alpha. I don't know that I've heard of this. What is aux alpha? Let's check it out together in real time. A mystery model called aux alpha just topped coding benchmarks for free. Huh. Whoa, man, this is what I love about you guys. You end up teaching me. This is the serious trick for a lot of professors. We end up learning more from our students than our students learn from us. It's very true. Okay, this is, so Centropics, you rock for raising this. This is freaking, man, I'm so pumped I went live this morning. We're going to check this out together right now. So this just got dropped on our lap from, oh, I got to give you some hearts for this. Okay. Boston, love it. Okay, can I get... Yes, I got it. I got you, Centropics. Hold on, let me switch over. I just want to check something real quick. Sorry for all the troubles. I know this is a little bit painful. Okay, does this one... Look, why does this thing write such crappy code? It's so frustrating. All right. I'll stop complaining and we'll just... We'll read about aux here in a second. We get back to the main screen. All right. So Centropics just made us aware of this mystery model called aux alpha. And this literally just came out yesterday. Okay. Let's check it out. Oh, sorry. Let me scroll this down so you guys can see this. Oh, I'll tell you guys about my harness and my... There are some people asking about my whole setup. And so what I'm probably going to do at some point is I'm going to try to get a second camera that's going to show you me from behind. And you can see exactly what's going on my screens, like the whole setup. And then I'll walk you through how everything is laid out. Because right now, you only see one of my 3 screens. But we'll save that for a little bit down the road. But for a lot of the dev stuff that I do, I live in Claude Code CLI. And then when I need to dig into the code, I bring up the code in various editors, including my editor guy over here. Right, so, because I'm kind of, I mean, big shock. I'm a little bit of a power user, and I just wasn't really loving a lot of the other IDEs. I just wanted something that was laid out in a way that was good for me, and I can still, mostly, I'm not writing much of the code, but I'm guiding the way that Claude Code does the development. Once in a while, if it gets really stupid on something, I'll go in and hack on it. But for the most part, what I'll do is I'll scan over it, and then I'll give it guidance on, what are you doing? This is like not the right way to design this. And so it's more of a high-level architecture kind of interface is what I do than sort of the hacker coding stuff that I was doing maybe in my late 20s and 30s. And part of me, you know, if I'm being honest here, part of me thinks that it's actually pretty cool, right? Like, I'm able to get a lot of stuff done really fast, especially when you have a blank slate. Yeah, blank slate work is, I'm going to be super real here. With the AIs, I think that it's a massive step forward. Now, to be totally fair, I think it's also true that the... Oh, hold on. Afro Rover is saying something really interesting. Put a pin in that thought. Have you seen your reel on deterministic and stochastic AI? Can go through that conceptually with a few hints on the tech, like examples? Yes, I can. Yeah, there's a few clips I did on deterministic and stochastic AIs, and I was going pretty fast. I knew that it would be a little confusing because it's just complex. But yeah, let me add that back to stuff to look at. We'll add it here. Goju to go back to Goju deterministic and stochastic AI. Afro, are you talking about when I was discussing the fusion? of how you use the two together. Is that the one? You'll have to remind me because um, I've been putting out so many clips, I kind of am losing my space. Yuri, there's a ton of things I could recommend. And as a matter of fact, I do teach class. I teach at Stanford, and this is the class I teach. And in fact, it's going to start next month. And any of the GTT people are allowed to audit it. So if you don't attend Stanford, that's okay. But you need to email me, so I add you to the audit list so Stanford's aware, because they like to keep track of these things. But you can email me, goju@stanford.edu, and then I'll add you, and you can sit in on any of the lectures. You can sit on one of them, you can sit on all 10 of them. You can go through the actual assignments and build a project and stuff. So, yeah, absolutely. There's several people I think that are actually flying in from different parts of the U.S. I don't know if anyone is coming in. Well, actually, I think maybe Elle. She's in. Where's Elle? She's in Italy, I think. I think maybe she's flying in for it. But yeah, in that course, I talk a lot about all the stuff on, especially the foundations, because once you understand the fundamentals of machine programming, a lot of the stuff that's happening in production makes a ton more sense, right? I think for most people that don't have a background in machine programming, and machine programming is different than machine learning, but if you are a bit kind of peripheral or light on the foundations of machine learning, machine programming, AI, that type of stuff, and then you start using these things, it can feel like it's kind of magical. And I think that's why a lot of people kind of get confused into thinking that they're sentient and stuff. But then when you understand the actual fundamentals, it feels, I think, at least for me, far more like tangible. You can kind of understand, oh, this is happening because I have this system designed this way. Like, for example, the reason why the LLMs are stochastic is there are stochastic elements that are at the base of neural networks, and there is different ways that the data is processing through the large system, the whole system, and some of that stuff can be interleaved. It has certain, the variance in temperature, so it allows some fuzziness, but there's a number of different stochastic elements to the neural net, which then cause that stochastic behavior. And that's really why it's stochastic. It's very much by design. And then the system, the AI system that we've invented, DIF, deterministic intent folding, it's fully deterministic. And that's because it's designed very much from ground up, where everything is kind of done in this specific serial order. And with that determinism, you get repeatability, interpretability, debuggability, and all the good stuff. And that's like a huge win, because it can be really hard to fix broken stuff in stochastic systems, because let's say that it does something wrong, and then you're like, oh, it needs you to not do that. And, oh, thanks, Yuri, I appreciate that. So it does something wrong, and then you want to fix this behavior, and then you make a tweak to the neural network or something, and then it doesn't do the behavior again. So that might appear like you've just fixed the problem, but it turns out that you actually didn't fix it. It just took a non-deterministic or stochastic path this time that's different from the last time. And because of that, you're getting this different output. And in fact, you haven't fixed anything. That then eventually, when you run it some number of times, you get these. Oh, that's awesome. Very. By the way, I think it killed our chat window. Give me 1 second, guys. My life is a little out of control. Restart the chat window. Dum dum. Okay. While it's trying to restart that, we'll go. Which one is it? It's this one, I think. Okay. Anyway, so the thing that I try to teach is I'm really keen on making sure people understand the fundamentals. Because once you understand the fundamentals, all of this stuff that can feel very overwhelming and complicated, it gets very simple. And I remember when I was first learning this stuff, it was very overwhelming. I remember first learning about neural networks, 20 years ago or something, and being so overwhelmed by the mathematics of it, and there's like a huge amount of linear algebra. But that's just because I didn't have, I think, the right kind of mentor that explained things at a conceptual level first. Because once you understand the concepts of what's actually happening, then you understand the architecture, and it's just much more clear. At least that's what I find. So anyway, I'm getting a little tangential here, or very tangential. So it's going to be a meandering day for sure. No, so Dylan, exactly. That's exactly right. That this is so on point. I want everybody to see this. Dylan's saying, I also think fixing one thing can also cause another random thing later to propagate in stochastic. That's exactly right. That's exactly right. It is a whack-a-mole. And because it doesn't have sort of a logical core to it, and I'm not talking about the add-on elements that do have logical cores, because I know that there are logical reasoners that are assisting the LLMs. Those details, I think, are pretty locked down and private, so I don't know how rich it is. I mean, I hear murmurings. But because it doesn't have clearly identified logical steps, when you go to change something, fix something, whatever, it's very possible that even if you do fix the one thing, it could break another 100 things. Which is why it's like, I'm very much of the mindset that determinism has to be the foundation of these AI systems. It really can't be any other way. Otherwise, it's going to drift off into never land, right? We're going to spend so much time just kind of throwing darts and praying that we got the right target that we're not really going to be able to reliably advance the science. It's going to be just brute force. And because they're stochastic, when you do change things to try to get the right behavior, you could inadvertently break a whole bunch of stuff, but you don't see it because the stochastic behavior just happened to be right for you that one time. That's like probably the biggest challenge with this, is that you can even run through all of these tests and everything looks perfect in your testing environment. And then you go to deploy it, and then it has a different computational signature, right? You have different interleavings or different orderings of the nodes returning inference results that change the way that the system is processing them serially. and then things just kind of blow up. So and just to be clear, stochasticity is awesome, right? It's what makes, I think, language models so cool, that stochasticity acts as creative ideation. It allows us to brainstorm and poke around. And okay, yeah, Amir, yeah, thanks for sharing that. We were having some weirdness with IG, and I tried to change it back, but if if you're having trouble with it, I recommend you hop on uh, YouTube. So I recommend you guys hop over here, and I'll drop that in the restream as well. Oh, thanks, Laksham. But this might be better. I apologize for the Insta did something kind of strange this morning, and I tried to fix it, but we might just kind of be stuck with it this time. Okay. So anyway, I want to be super clear, because I think I somehow like get misquoted or misunderstood on this. I'm not against stochastic AI. I think stochastic AI is fantastic, but it has to be set up properly. It has to be a stochastic system. Oh, awesome. Thanks, Zach. It has to be a stochastic system that runs on top of a deterministic system. And the reason for that is then the deterministic system can act as a validator, right? So basically anything that the stochastic system tries to do, it can't actually get out unless it passes through that deterministic hypervisor. And this is the part that we don't have the capability of today, at least to the best of my knowledge. And what that means is you have like small segments, you have small slivers where you can do deterministic analysis for stochastic elements, but they're really small. So they're pockets, right? There's literally just like tiny little pockets where you can do the deterministic validation, and the rest of it is just a big gap of just goes right through. And the reason for that is the way that we've done these deterministic validators, verifiers, various formal methods, is they're really compute heavy, because basically you get state space explosion. Is you have to walk down this tree, and every time you take another step in the tree, it blows up into 10 more nodes. And so one step down is 10 nodes. One more down, it's 100 nodes. One more down, it's 1,000 nodes, right? And so it's just and this is just like to do 4 operations or something. That's really restricted to the grammar of possible outputs. That's kind of how that works. And so we don't really have a technique that I'm aware of that can do full validation of the stochastic systems. And that's something that is like really important for us to try to figure out. This is kind of why I invented the diff system. Is diff was meant to be diff is a semi-formal system. Anyway, we'll get more into that later, and maybe when I start teaching my class. I think I've got a couple lectures on this. Yeah. Anyway, I want to go back now to our mystery model. But hold on, you guys are having some really good comments, so I want to take a look at these as well. Um, Jeremy, uh, I'm not sure I totally understand your comment of, so you have to reach the metal for control under deterministic models, and you can't use CUDA on backends because it won't give identical bits. I mean, that's kind of part of it, I think. And basically that's, you really just need, when the LLM is doing inference, what you want to do is have that output go to the deterministic system, which can also be an AI system. It doesn't have to be a deterministic heuristic of something that you coded, right? That's kind of a misnomer. And then that system verifies that things look correct. And if it doesn't agree with the output, then it sends it back and says, no, stochastic system, that's not correct. Fix it and try again. And that's actually what we saw, I think, in the last live stream when I was showing using diff with Opus 4.6 and how the results got significantly improved. Because once the stochastic systems actually know the piece that they've kind of messed up, they tend to be able to improve on it. They just kind of don't know. They don't really have a good rating system to tell them what they've kind of messed up. So you probably see this in your own work using these systems, right? Is you'll have it write a whole bunch of code or write a paragraph or build some image or whatever, and then you'll hone in on a specific piece of it, right? And say, okay, this looks good overall, but this piece right here is super bad. I don't like this. Fix this. And then the next time, I mean, depending on the AI system, it might change everything, but sometimes you might get lucky and it might just change the one thing that you're trying to get it to change. And then it changes that, and then things are better. But it can't do that on its own because it doesn't know that that part is messed up. It doesn't have the ability to kind of grok that. And that's basically how the deterministic systems work, is they kind of like almost replace us. And that right now, we're kind of the validator for the stochastic systems. They give us the output, and then we say, no, wrong Claude, wrong codex, wrong whatever. And then we give it this guidance. Hey, Michael, what's going on? Oh, yeah, so Running Man. Yeah, this is pretty cool. I think for this stream, I'm going to be pretty scattered, and we're just going to kind of follow the chat. We're going to do that today, since I really didn't have too much planned. But at some point, I want us to actually read through this article that on this model that we just found out about. But okay, so going back to Running Man's question, I don't understand exactly what you mean by calling the AI stoic. So just to be clear, so I'm actually calling it stochastic. And hold on, let me. Yeah, okay. Give me a second. I'm going to see if we can find some assets that spell this out. Talk amongst yourselves while I try to find this. I know I have an image or images that we were creating, me and my buddy Claude were creating last night. Oh, this is on self-supervised learning. Oh, and by the way, guys, for any of you that are not on our Discord, I'm dropping all the assets that I'm creating in our Discord channel, and you're free to use them however you want. Like, but you got to be part of our Discord to get them. Yeah, right here. So I dropped. So I've been dropping some of these in here. and they're basically there for anybody. So here's the link to the Discord. And also, if you join the Discord, then you'll kind of stay up to date on when all the live streams are happening and any other kind of major things, like the course at Stanford, all that stuff. Okay, so the question was about stochasticity and what that means. So let me see if I can find. Oh, here. Okay, I think I'm close, guys. Okay. And by the way, I really love these questions because, as I think all of you guys know, my goal, the thing that like I really care about, is trying to make sure that we all understand. Like that's the reason why I teach this and why I do GTT is I want everybody to understand how this all works, so then we can work on it together. And so here's a kind of a simple picture on this. Wow, man, you guys are on fire today. Okay, I love this. We're definitely just going to follow the chat. This would be like my new Saturday thing. Now that we've got a pretty large army of regulars, which I love, by the way. We're getting on average anywhere from 40 to 50 people on pretty much all the live streams now, just as an FYI. I mean, if I announce it. Anyway, so let's first try to explain these two sides, and then we'll see if I have some other better pictures. Okay. Now, neural networks, which are the foundation of transformers, which are the foundation of language models, are stochastic machine learning. And by the way, in the hardcore research community, AI and ML are not the same. You know, ML is a subset of AI. AI is like this bigger thing, and you can do like artificial life and other sort of non-machine learning things in the space of AI. And a lot of us in the scientific community are kind of like annoyed that they've hijacked these words and are not calling it this. But that's just me being a little pedantic. Anyway, so in all of the language models that exist today, every single one, to the best of my knowledge, they're all based on neural networks. And neural networks are inherently stochastic systems. They're stochastic for a variety of reasons. They're stochastic because the neurons on initialization of the network, before you start to train it, they have to be randomized. And so basically you have this, let's see if we can get a picture of a neural network. What's going on? All right, this will suffice-ish, I think. All right. So these guys here, these are all the neurons. These are the individual, well, the input layer, this is, yeah, this is actually just the input vector. But everything inside of here, these are all the neurons related to the system. And each of these neurons are essentially a weight. They're just a value. And when you're setting up the training for the neural networks, all the values of these things should be randomized. They should be pseudo-random. If you don't make them pseudo-random, what can often happen is they won't converge, so your likelihood of convergence will decrease significantly. And on top of that, if it does converge, you sometimes get these weird symmetric convergent properties where it's like it kind of gets to the answer, but then it does this weird thing where it shapes the answers to be like identically balanced. So you're like asking it to distinguish between apples and oranges, and then it just decides that all apples will be 50% and all oranges will be 50%. This is what happens when you don't randomize it, right? But the big thing is the likelihood for convergence decreases significantly. So you have to have these things be randomized. That first piece is one of the core reasons why these things are stochastic. Because if you take this topology and then replicate it, make it exactly the same, but initialize the weights to be something different, and you train both of those models on the same data, they will not converge. They will diverge. And what I mean by that is they may still converge on the answer. So they may still get the same, like both of them get 98% correctness, right? So on the surface, it looks like they're the same. But when you look at the actual neural network, they don't have the same weights. And that's a problem because that means that their behavior when you run them in real time, when you do real-time inference, they won't always give you the same answer. They just give you that potentially for the testing data set and like the validation data set. Now, there are other aspects of stochasticity for the language models. And again, as a reminder, neural networks at the base. Above that is transformer. That's a specific type of neural network. And then above that is essentially LLMs. The distinguishing factor there is transformer is an architecture of a neural network. But then when you're building an SLM or an LLM, you have different ways that they run. And the ways that they run fundamentally impact their determinism or their stochasticity. For example, if you run a language model on a cluster of nodes, a cluster of compute nodes, like a 100-node data center, what will happen when you run inference is the inference results will come in out of order. And then when you assemble those, it could give you a different answer than if it was assembled in a different way. This is from basically a seminal paper that Chris Ray and others wrote on Hogwild, right? Wow, we're really going. You're really testing my knowledge here. This is great. Wait, is somebody spamming? Oh, is my volume? Is my volume low? Okay, it's interesting. I'm not seeing any spam here, but maybe my system is blocking it. Sorry that somebody's spamming, and thanks, Cyber. Appreciate it. Hold on, let me... GV... Oh, it's interesting. I don't even see him. Okay, so basically what Hog Wild shows, yeah, this came out like 15 years ago, is that if the inference results come in out of order, it'll still converge. And I think that that's right-ish. Right-ish. Be super clear about something, is that they will potentially have the same convergence and get approximately the same correctness. But this is super important. Like the actual neurons and their weights will not likely be identical. This creates another element of stochasticity. Okay, so here's the new situation. Now you have two neural networks and they are the same. Okay, everything's the same. Topology is the same. The weights are the same. And you're going to go through training, right? We're not going to do inference yet. We're just training the system. And in that training, we're going to put them in two separate clouds. Because we use things like Hog Wild, right? And why do we use Hog Wild? Because it's fast. Because if you introduce any form of serialization in the training, you get this thing called Amdahl's law that kicks in, which essentially the serialization eventually becomes the bottleneck. So the idea with Hog Wild and other approaches like it are you don't have to do any locking. You can just let it be a free-for-all. And then because of the way these systems learn, they will eventually converge to like the same answer. Ish. This is super important. It will not be identical, but it will be close. It'll be close enough to where it's like they may give you the same answer for all of the training data or the testing data, but the actual neural network underneath is not the same. Okay, so here you have these identical neural networks, same topology, same like identical weights in them. And then you go to train them and you use something like Hog Wild, two different clouds. What you get is potentially two neural networks that converge, basically give you the same approximate answer on things. But the neurons, the actual weights inside of them, are different. This is the second element of stochasticity, right? And keep in mind, in order for them to be like fully identical, you would have to create a serial order in the way in which the inference results are coming in for the training, right? Because like the inference, when training, you're still doing inference. It's just that rather than just giving the result, then you look at it, you calculate the error, and you do backpropagation, right? So what I guess I'm trying to say here is that it is true that these mechanisms will essentially give you a similar type of convergence, but it's not identical. And that stochasticity is creating problems for us, right? So hopefully you can start to see now where the stochasticity is coming from in these neural networks. The big reason why this is really a problem, this is probably the most important reason why this stochasticity is really a problem. When you are training the system, it's very hard to get identically repeatable results. So I'm not talking about cases where you're running inference and like you absolutely can get deterministic output on SLMs, like single node language model, turn the temperature all the way down, ensure the inference results are happening in a serial order, and you're going to be good to go. Right? That literally, you can force it to be deterministic. That's not the problem. The problem is when you're trying to improve the language model, right? You want to come up with Opus 5.1. Now, because it has that stochasticity, when they try to improve it, they're going to see the like, oh, awesome. Look, it's getting all these great results. This is so amazing. Let's ship it. And then they ship it. But then what actually happens in production, what you actually see for the users, turned out to be something totally different. And then you get kind of these subpar results. And I want to be like, try to be as fair as I possibly can. It's not even the fault of OpenAI and Anthropic or the other AI vendors. They're doing their best, but they're building on these stochastic systems, which is part of the reason why me and Jan LeCun and other people are kind of like, this is not going to work. I mean, it's a flash in the pan, because you can't, like, fundamentally, the science of the world, all the scientific advancements that I'm aware of that have pushed the human species forward to where we are today have been built on deterministic science. That's kind of the scientific method. You know, the scientific method is basically run these experiments, collect the data, and then iterate. If the results keep changing, that iteration part becomes almost impossible. And we need that iteration for like everything that we do. All the hardware that we have, the software that we have, right? Like anything that's going to be useful in the world, at least from my perspective, in science, is going to require us to iterate it, because there's no such thing as like a one-off scientific method. We don't kind of like just do science like we would do a piece of art and say, okay, I'm done, right? It's just, that's not how it works. So, okay, cool. I think I've really beaten this horse, but that was a question that somebody had way back earlier. So my hope is now we all understand the core reasons, or at least some of the core reasons, why neural networks are stochastic. And anybody that tells you that neural networks are not stochastic, they either are selling you something or they do not understand the science. And it's actually kind of interesting is when I first was trying to compel people to like adopt deterministic AI, some of them would argue that neural networks are deterministic. And it's just like, why are you saying this? It's just not. Stop. Anyway. Okay. I'm going to rest my voice for a second. We're going to look at some comments, and then we're going to go back to learning about this guy. Actually, maybe now is a good time for us to take a short break. I may be actually somewhat compelled to do a long live stream today, just because I really like to do the meandering. And so if we do that, the general rule that I have is we have to take breaks every hour, so I can bio and refill my soda. So let's take our first break right now, and we'll give it 5 minutes so you guys can run to the restroom. Repeat what, Dr. Creep? The whole explanation of stochasticity in neural networks? I will murder you. Okay. Yeah, so Running Man. Yeah, yeah. So Stoic, actually, just as an aside, Stoic is kind of the way of life that I try to live from Marcus Aurelius. There's this thing called Stoicism, and it's kind of like about emotional regulation. Yeah, Dr. Creve, you're hilarious. Yeah, no, we're not doing that again. Okay, so let's take a quick 5 minute break and call this break number one, refill, soda, and stuff. There we go. Okay, let's give it 1 more minute. All right, guys. You got 6 minutes, do your stuff, and I'll be right back. This is going to be awesome. Okay. Back before. Yeah, you are trying to test to see how stoic I really am. I know it. Is there a TLDR version of the stochastic versus deterministic AI? Uh, that's a really good question. I feel like there should be. I know I talk about this somewhere in my class. Yeah. I mean, yeah, that's a really good way to describe it. Dr. Creep. And there's, there's one part of this that I'm a little, I don't know that I have for sure figured out what I think about this, but in the ML space, there's this belief that there's sort of two different ways that inference is happening. There's the inference, which is doing classification, and then there's inference that's doing prediction, right? Two different things. And people will argue that the way you design a neural network that's going to do predictions are very different than the way you design them that are going to do classification, right? So the classification one is you show it an image of something, and then you say, what is this an image of? And the prediction one is you give it words in a sentence, and then you leave out the last word and say, what is that word? Okay. So, oh, awesome. Syntropics. I'd love to hear about it. But anyway, so some people are very adamant about this, about how you got these two different paths. And like, I don't know how I feel about this. I'm still a little bit up in the air, because I definitely think that when you're doing things that are kind of prediction, they tend to be done in a way that requires some statefulness for a serial order of events. And that's kind of what transformers do, right? Is they take in a bunch of input data in a single pass, and then it's like staggering the results so one leads into the other. This is sort of the big advancement of transformers over long short-term memories, which was the predominant way to do prediction-related things or time series-related things before transformers. Now, the big difference between transformers and LSTMs is the LSTM is a recurrent neural network, so it's holding statefulness in its memory, where you have like a back edge. And so you still give it like one piece of data at a time, but then it's like accumulating stuff over some window of time, and then it gives you the answer. Whereas transformers are essentially taking the serial input all in a single pass, or some portion of it, and then from that, it's doing the prediction on whatever the next thing is. Okay. Now, why would I say that, like, when you're doing prediction and classification, they might not be different? Right? So, in both mechanisms, you're guessing. It's what you're doing. Ultimately, no matter how you do this, you are speculating on the answer of something, right? Now, I'll admit that the way that you speculate the answer for something that is like a time series, it is different. Hold on. I just need my back pillow here. When you're doing the speculation for a time series, yes, it's different because you're kind of accumulating things. Whereas when you're doing a classification of something, like classification for an image, it's very possible that you just have the single image, And you could argue that that's fundamentally different. But I am still not convinced. And by the way, I want to be clear. I'm not saying that I'm positive that prediction and classification are the same. I don't know that either. But I kind of feel like prediction and classification, it's like is it an artificial segmentation? Right? Are we artificially separating these two things when they're really the same because they're both predictions? Anyway, I've thought about this quite a bit, and I don't know or don't claim in any way that I know what the answer is, but I just wanted to share that with you guys because I think it's a fascinating discussion. Let me check some of the comments here. They're both compression. What do you mean? What do you mean, Dylan? By comparing custom chain execution layers designed for matrix operations with optimistic fraud proofs, this setup creates an incorruptible autonomous intelligence capable of managing real-world assets. That sounds pretty sophisticated, but I'm not sure I know. Where'd my vape go? Oh, here it is. I'm not sure I understand what you're asking or saying, Centropics. Yeah, I know, right? Right, NM? Exactly. Oh, I see what you're saying. Yeah, okay. So I think that, oh boy, okay. Whew, this is going to get complicated. Okay, are you guys ready for this? Like, we're really going down the rabbit hole. All right, the way that you look at data coming into these models is there are a lot of arguments for reducing the dimensionality of the data. This is what it means to be looking at these things in latent spaces. The latent space is essentially a simplification of the dimensionality, so it's easier to reason about. But there's arguments actually that I have that there are hidden data when you do an increasing of dimensionality. And when you increase the dimensionality, you can get more richness. Because when it's increased, you see things that are not visible when it is in the latent space. Okay, so that probably sounds super confusing. Let me give you an example. If you look at, yeah, dimensionality, exactly. So you guys all know about deterministic intent folding, I suspect. You know, it's the thing that, it's kind of the basis of how we built the mentor system. And the I piece, the F piece folding is the dimensionality increase. All right, so what does this mean? Let's take a simple example of looking at code. So you can have code that is, okay, yeah, and I should finish the white paper at some point. My life's just been total chaos, but eventually we'll get that done and I'll publish it so you guys can all read about it. But with that system, it talks about this folding element. And with the folding, it's meant to increase the dimensionality of the thing that we're looking at, because more things are visible when you look at it potentially in a higher order representation. So the folding is similar to things like protein folding, right? That's actually what they do, as I understand it, sort of peripherally with the protein folding work. Is the proteins are sort of in these two-dimensional spaces, and then they up-level it to a three-dimensional space so that it actually shows how it's modeled in the real world. Okay, so now if we take the same concept and apply it to code, you can do folding activities in the way that you visualize code. That code can be read just as a sequence of instructions. And that's kind of like in the two-dimensional space, right? Like we can look at this code over here and say, okay, it's just a two-dimensional space, and maybe I read it linearly, and that gives me some understanding. But now you could think about it in like a three-dimensional space or a four-dimensional space, where instead of just looking at the code in a raw form, you can think about the way the state of the program changes as the operations of the code get executed. And when you do this, there's now more data. There's metadata. There's statefulness. There's other stuff that we're seeing that you don't see when it's just in two-dimensional representation. In particular, one of the, I think, most important ideas for machine programming is in this space of repository lifetime reasoning, where you aren't just looking at the code as it is right now. You're looking at the code as it evolves over a period of time. And with that evolution, it starts to tell you things like what the intention of the code is, like what people were trying to actually get across when they were constructing this code. Now, it's very hard to see intentionality if you just look at a single snapshot of the code. But if instead you look at how the code is evolving, then suddenly you have more understanding of what's going on, right? This is what the F stands for in diff. This is the folding piece. And so when we talk about dimensionality, it's very interesting because there's a lot of prior work where people have done dimensionality reduction for latent spaces so you can make the problem more computationally tractable, right? This is kind of the reason why you bring it down into a latent space, is it just simplifies things. There's less work to do, kind of thing. But I think there's also this space where you should be increasing the dimensionality because there's more richness that you can observe when you change the representation of the data from like a lower dimension to a higher dimension. So in the diff system and in the future AI systems, what I think is it's actually like a fusion of the two. I think you want, in some cases, for the data to be unfolded, and that may have value, right? Like for what we're describing with the latent spaces. But then in other cases, you might want to fold it because then the data is more dense. And that can be valuable for things like transmission, right? Like somebody was saying about compression. And there's something about, somebody was talking about, oh, yeah, yeah. Right. Dylan was talking about compression. This is what sent me down this rabbit hole, by the way, because when you get into the more advanced stuff with diff, that compression part is one of the key things that kind of unlocks some of the power. And in particular, the big one that we were looking at with the mentor system is the compression that happens in either like structural representations of code. So you do, this is like getting pretty deep. You do transformations on the code structure that then capture essentially all the semantic information, but it loses some of the like verbosity of it. And you sort of wave away some of the extra clutter that is very useful for humans, but not super useful for machines. For example, in the code that we're looking at here, these function names, the reason why these exist for the most part is to help us humans kind of understand what this thing is doing. So test UI, click cursor, wrap aware mapping. That's not there for the compiler. The compiler doesn't care at all about this. But a human that's trying to read this and understand what it does, it's very helpful. Now, if you wanted a machine to process some of this, what you might do is do transformations on all of these names. So the names become massively simplified because each of those characters, right, in their native form, that's space that you have to somehow deal with. And so like the longer it is, the more compute intense it's going to be. So if you can do a compression here and reduce this down to another kind of simple mapping that takes one or two characters, you can actually do more compute on this because of the structural representation of the code. And it may seem like it's kind of like super obvious, but there's a lot of stuff that happens with like higher level representations of code in programming languages, specifically things like abstract syntax trees, that don't do this. And it's like, okay, you can go even further than this, is that rather than just giving it a remap name that's shorter, what you can tease out is the intuition of what the object or the thingamabob is. So we could rename this test UI click cursor wrap aware mapping to something shorter. But we could also rename it to something that is special, that tells us that it's a function. And we could do this so both things are being done at the same time. And that's really beneficial for the machine because the more we can reduce the symbolic overhead, the faster the machine can process these things. This is why, numbers are super valuable because they're like a very dense space, whereas characters are like the fact that you can only capture 26 variations in what is it, like an 8-bit char. That's a huge amount of wasted space, right? Because you have a full byte and That's 256 numbers that you could be capturing. Hey, Dark, what's going on, man? Okay. So, guys, we're getting super deep. And now we need to back it up a little bit because this is going way heavy. And I know people's brains are going to start to explode if I continue going down that rabbit hole. So we're going to ease off the gas and we're going to look at something that is going to be a little bit more accessible, which is this guy. We're going to read about this. Oh, and I want to talk about the OpenAI stuff and Anthropic stuff on this data retention. Okay. And wait, did anybody have yeah, let me quickly go through some comments there. Hi everyone, I work in infrastructure and I'm an AI enthusiast. Oh, awesome. I'd like to learn and be part of this community. What do I need to know to understand the topics discussed here? Well, welcome, Lucas. We're super delighted to have you. And yes, and that's exactly right. Latent spaces really have to do with reduction of dimensionality. What is a latent space? Oh, what? I can't type. Latent space. Latent space is hidden compressed map where artificial intelligence stores information. It turns big things like photos and words into simple numbers. It puts similar ideas close to each other in the space and helps the AI understand meaning and make new data. Key features: small size, right? Small size, it takes big data and makes it tiny by dropping the extra noise. That's the key thing about the latent space, like we were talking about. So it's that dimensionality reduction, right? And then there's an approximation association to things in the latent space. You kind of like cluster similar stuff together. That's super valuable because then you can do things like k-means clustering and nearest neighbor. So then the numbers are not just numbers; they contain semantic information. Now, hey, thanks, Dark. Appreciate the super chat. Now, I want to be clear. This is a little bit of a problem, though, because while you get the semantic information that's embedded in the numeric, right? So what I mean is that the numbers are clustered together to mean something, like it's the movie genre, or it's the type of music, or whatever, right? Because it's just a number, there's no notifier, there's no signal that's telling you what it is. So you have to have another system that's telling you what the numbers are representing. So this is a bit of a problem with the embedding spaces, right? We need, there's like more work to do here. And trying to think. I think we came up with some clever things at Merly, but off the top of my head, they're not coming right yet. But anyway, okay. So, oh, Lucas. Yeah, so one of the things for new people is to join the Discord. We love that. And there's, by the way, this is actually pretty awesome, guys. We almost have, oh my gosh, you guys are freaking amazing. Look at this. 10 new Discord members just from this live stream. Oh my gosh. Like, I'm telling you, before we started the live stream, this was at 0. So I'm so pumped, guys. Like, that literally just made my day. Yeah. Now, it'd be even better if you guys were all members on the YouTube thing, because that little 99 cents a month, that adds up and keeps me funded for all the one-off mumbo jumbo I have to pay for, like Restream. But anyway, going back to being part of the community. So Lucas, we're going to be doing a whole bunch of things. We do the live streams to talk about all kinds of things related to AI. And really the goal with GTT is I wanted to bring together people that care about technology and AI and science, but are sick of all the BS that's coming from like big tech and some of these super rich startups like OpenAI and Anthropic. Maybe more OpenAI than Anthropic. Although even Dario, I do think sometimes Dario is going a little too hard with the LLM thing. And I wish he'd stop, because I know that Dario is a very smart guy. I know that he knows you can do SLMs. Like, he knows enough to not be kind of selling that story. I don't know why he keeps doing it. Whereas Sam Altman, like, I don't have any hope for that guy, right? I mean, Dario and Sam are not the same. Like, I do have actually a little bit of respect for Dario, and I've got none for Sam Altman. Anyway, so being part of the Discord is great, and then we've got the main YouTube channel. I see that you're on IG, Lucas, but if you go over to the YouTube channel, we've got the massive collection of stuff, like a whole, just a ton of lot of things. So yeah, so welcome. Super glad to have you here. And thanks, Digit. Glad you're here as well. Sorry, what is LMGTFY? What is that? Did you LMGTFY? Meaning? Let me Google that for you. This is sarcasm. Okay. Sweet. Okay. I think we're almost ready to go back to this. I just want to check to make sure I'm answering everybody's questions. This is probably the most exciting part for me. Do the locusts always have to reside in only one dimension? No, I don't think so. No, in fact, I think that some of them can only be observed in higher order dimensions, which is part of the reason why you need the folding, right? Because you could have two pieces of data, right, that appear to be very far apart in a two-dimensional representation, but then when you add the third dimension, they might converge to being like right next to each other. So sometimes this is a great question, Michael. Sometimes adding more dimensions, this is actually what I mean about the stuff that happens when you add more dimensionality. Like, I think you guys are really grokking the essence of this. It's like the more dimensionality you add, the more things you can potentially observe that may have been hidden before. So yeah, great question. Ahmad is saying that he just started testing Ox Alpha, and it's awesome so far. I'd love to hear what you're using it for. And let's take a look at this now. This is on Startup Fortune. A mystery model called Ox Alpha just topped coding benchmarks for free. Woo! Okay. An anonymous AI model called Ox Alpha appeared free on Open Router and Open Code this week, with a 1 million token context window. Yeah, that's pretty good. Strong developer reported coding benchmarks results. Nobody has confirmed who built it. What? What? Is that real? Okay, guys, this is yeah, that's right. Yeah, give the likes, damn it. Thanks, Dark. um Nobody has like taken ownership on who built it. That's super fascinating. That is okay. This is like the story is getting far more interesting now. Does anybody have any idea? Okay. Anybody that's using it, do any of you guys have thoughts on where you think it's coming from? Are you seeing, okay, let me ask. Are you seeing slang that would give you an indication that it's like American English, United Kingdom English, other little hints, like if it's Western European, it might use commas instead of dots. I'm trying to figure out if there are contextual clues that we can use that might give us information about where this thing is actually coming from. Because I'm far more interested now than I was at the beginning of this live stream. Okay, let's dig in. And by the way, this was just announced, what is it, yesterday, right? We're August 22nd. This came out. So this is all super fresh news. And by the way, thanks, I think, Synax or something. You're way up here, brother, on this. Yeah, and let us know. Okay. All right, Ox Alpha is the kind of free AI preview that gets developers moving fast, but the useful story is not a mystery lab guessing game. It's what you can verify before the window closes. Ox Alpha appeared on OpenRouter with Model ID Stealth Ox Alpha, and OpenCode pushed it to developers as a free model for the next week. No lab name is attached. No founder is taking a This is wacky, guys. This is wouldn't be surprised if it's from Z. Do you mean ZAI, Bishop? Dr. Creep, I can't take credit for this. This is not us. Or it's not me. Maybe somebody else from GTT. But there are theories from footprints leading to ZAI in terms of similar function, output, especially without randomness. Very interesting. Yeah, wacky in, okay. Hey, Zach, what's going on, brother? Yeah, man. From Threads? Is that you, Zach? I love it if you are. Wacky in potentially really good, but also a little bit scary in that, you know how I've talked about some people building Trojans into language models, especially SLMs, and it makes me a little nervous. Mackey's, hi Gojo, I'm planning on going for applied math PhD. I was wanting to get your take on some avenues of good research as I want to distance myself from the LLM domain. Oh, that's awesome. I love that. Hit me up, Mac, and we can talk about this a little bit offline, but yeah, it's actually really interesting when this whole LLM hype and buzz first came out, I was pretty, like, I was kind of annoyed with how much hype was going on and how there was just like, I don't know, it felt like the whole world was kind of drinking the Kool-Aid for LLMs, including my Stanford students, right? So in, what year was it? 2024. Because I've been teaching machine programming at Stanford for, I think 5 years now. And I think it was a 2024 class. At the beginning of the class, I had a room full of, I don't know, maybe it was 50, 60 students. And they were all going crazy about transformers and LLMs. And I said, I'm not teaching transformers in this class or large language models because I think it's super boring and it's all the rage. And there's so many other really important things that exist in the space of machine learning and machine programming. And basically everybody is teaching transformers and language models that I'll let them do it and be like massively saturated. I'm going to teach other things. So I said this in like the first or second lecture. By the following week, I think 75% of my class dropped, right? Not kidding. It was like, yeah, it was like 75%. So I went down from, it was maybe 50 or 60 students. And I was down to something like 15 or something the following week. And yeah. But I want to say that excitement of that, I think what it was is, okay, look, I've been doing AI and machine learning since 2007, right? I think I first started teaching neural network architecture. Truthfully, the first courses I started teaching on AI and ML was neural network architecture. So like, I love neural networks. They're great, but there's just a lot of other stuff than just neural nets, right? I don't, this whole one-trick pony thing, really, I think it's silly. So I think what happened is I could kind of see where this was going to lead, or sort of that this was going to be a little hypey and it was going a little bit too far. It was like the only solution that existed was language models, and I could just kind of see the deer in the headlights kind of thing. Just, it was strange. But admittedly, I probably saw that just because I've been working in this space for a very long time. So for a lot of other people, I get it. They hadn't known about neural networks. They hadn't been teaching it or building these systems for 15 years. So for them, it was new. For me, it was old and established. And I'd already built like at least a dozen or more research systems on neural networks. I had published at least a dozen papers and patents on this. So this was a little bit more old hat. But I think what's happened now is a lot of people are now where I was back in 2023. Admittedly, when things started getting really hot early or late in 2022, I was somewhat excited about it. But then I kind of started digging in and seeing a lot of the weaknesses. Anyway, yeah, that's awesome. Yeah, the chat for YouTube and the layout, I think, just is generally better. Awesome. Look at that. Another person joined on the Discord in the time we were just looking at it. Okay. Goju Control Center doesn't show when someone joins GTT. Oh, it doesn't. Oh, did somebody just join? By the way, the membership on the YouTube is pretty awesome. I think we're like over 80 people now. So thank you guys for that. I love that. Uh, Cam Devs is saying, I'm shocked Fortune 500s are forcing people to use LLMs with promises from sales of some winter wonderland, and now everyone is fighting the behavior of them while massively adopting and investing. Exactly. Like, I'm really curious to hear what your guys' take on is this. So for the people that have been actively using the AIs, chime in, share with me what your experience has been. Hold on. Let me see if I can create a poll. I can't remember how to do this, but let's see. Okay. Did I do P4? With LLMs. And then I think I do A1, good, A2, mid, A3, painful, and exhausting. Okay, I want to do this. Now, I suppose if I hit Control Enter, maybe this works. Okay, Control Enter didn't work. Control Enter. Tab. Oh, come on. Oh, maybe is there a help on this? Shift tab. Or maybe I do this. Poll like this. Let's see. Control Enter. It's not working. Hold on. Let me ask. Claude will know. I want to get this poll out. This is going to be great. Because I have a feeling you guys may be having, especially for those of you that are using them heavily like I am, I have a feeling that you probably are getting some sense of frustration like I am. That's my speculation. Not trying to bias the poll. Claude, how do I enter a new poll in GCC? Control Enter isn't working. Can you tell me? Okay, Claude's going to remind me on how to enter in a new poll. Oh, awesome. Yes, this is exactly what I want. Dark. So any of the rest of you that are using the LLMs pretty actively, I would love to hear what your experience is like. Yeah, I don't know what's up with that, but I'll look into that. No, I think it'd be a good assistant. I find decensored versions are way better and objective. Yeah, the censorship stuff is... Frontier AI have way too much bias and manipulation and lying. Oh man, the lying and the assertions of things. Love Gwen 3.5 uncensored. Interesting. Very interesting. Oh, Control J. It's saying Control J. Hold on. Boom. We got it. All right, cool. So here for everybody, I'm curious what your answer is. So the way to answer this, you can just type uh, A1, A2, A3, or hold on. Yeah. Or you can type P4 space A1, A2, A3. So I'm real curious what everybody's answer is for this poll. How is your experience with LLMs? Good, mid, painful, and exhausting? And I'm just going to leave this up over here. So Zach came in and okay, a couple of people have come in with mid. Yeah, exactly. No, I mean, I get into a level of frustration on things that it's like, it's really interesting because I think that they are extremely powerful, but it also reaches this like pure exhaustion of trying to get it to do some stuff that a normal human would know and understand almost innately, right? And it just can't figure this out. Like, for example, I have it work on the cards for me, and oh my gosh, I am dropping the F-bomb on Claude constantly. It's like all caps. And it doesn't start out that way. Like, I'm pretty chill at first, but then when it keeps making the same freaking mistake, and it's something that's so obvious, right? It's like in some of the cards that I'll create, I'll ask it to just be smart about the way that it lays out the card. And it will do stupid things like it will run the text over the end of the bounding box, right? Like no normal human would make this mistake. Nobody would make this mistake because we would just look at it and be like, well, obviously you don't want that. And so some of the things that it does wrong are the parts that I get the most frustrated about. And I think that part of the reason why I get so frustrated is it has a level of expertise in things that give you this false sense of high degrees of intelligence, right? It's like it's doing stuff and you're thinking, wow, this is like Claude, you're killing it. You're just dominating. And then it reverts back to having an IQ of like 20 points for stuff that you would think something that's at like a super intelligence level would never make this mistake on. So it's sort of like this idiot savant kind of duality, duplexity, or whatever the word is. It's exhausting. Okay, so you guys aren't getting nearly as painful and exhausted with them as I am, and that's cool. I appreciate your your chillness about this. So overall, people are saying we got 10 votes. People are saying it's pretty mid, and then there's some folks that are feeling pretty good about it. Yeah. It's a dystopic machine that spies on you, aggregates all your data, knows more than you tell and lie. Oh, yeah. Yeah, for sure. 100%. Crypt, this is where it's going. I I don't think I have ever been more confident about a prediction of technology than I feel about this. There's many reasons why I think that the future of AI is SLMs, but is one of the biggest reasons is that the economics of the AI systems when they're in LLM form are just it's it's not fiscally uh, reasonable. They cost too much money to do the kind of very simple things that we're asking them to do. For example, if you do like a search in Google, the amount of compute that it has to do for that database lookup is extremely lightweight, right? There's all these interesting optimizations on indexing for the database. And yes, it doesn't give you the super creative answers and all of that stuff, but you're going to get answers really fast, and you're going to have a lot of accuracy on the answers. Yes. When you do that same type of search for an LLM, I don't I haven't done like the full analysis of the compute, but I'm talking it's like 1,000x more compute heavy. It's not like a 2x or a 5x. I mean, we're talking orders of magnitude more compute. And why do we need that for simple things like the search? I mean, sometimes if it's a complicated question, I think that the AIs can be really valuable in the answers that they provide. But the other part is you can make them hyper compute lean if you specialize the domain. And I think that's the big advantage of the SLMs is they can become super specialized for just one particular thing. And the trade-off is really generalizability, right? That is the big trade-off. And I think that's fine because then you just have different SLMs for different topic areas, and then you bring them in and out based on what you need. So I like just the pure economics of LLMs do not make sense. And we're kind of seeing that now with them increasing the price or pretending, like trying to hide the price. But that can't be continued to be subsidized by investors, right? Now they want to IPO, so it'll be subsidized by us, by the public. And I think that there may have been a period of time when that was going to work. But I feel like that window has kind of passed. Because I do think that, like, one of the things that I'm seeing with the general view of AI is while there was a huge amount of curiosity about it back in 2022 and all the way through 2023 perhaps, I think that because the AI industry has gone out of its way to try to promote how AI will replace humans, especially in their job, they've done themselves a massive disservice, right? That now for a very long time, people were losing their jobs to AIs, which are not even able to do their frickin' jobs, right? But there was this whole lies from the C-suite folks believing that you're going to save a huge amount of money on hiring these AIs because they don't get tired and they don't need healthcare and blah, 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 all this stuff. And then it turns out that, oh, they actually can't do even the most basic things, right? Because they don't have common sense. Common sense is probably one of the biggest problems with the AIs. And the common sense part comes from not understanding the semantics of things, right? Like the AIs don't know the difference between when they are writing a program that's going to be useful for, I don't know, like taking notes or drawing pictures, or they're creating a program that's going to hack into some financial institute. I mean, they kind of do now because of the safeguards, the guardrails that people are putting on it. But a lot of that is just sort of programmatic added in. So because they don't understand the semantics of things at a core level, because many of the safeguards are sort of this, they're done in a very clumsy way. By the way, this is, I'm kind of bouncing around here, but if you go back to the discussion of when OpenAI hacked Hugging Face, there's a lot of discussion about how Hugging Face used GLM 5.2, I think, GLM 5.2 to then identify the hack, because they knew that they were hacked or they had a security breach, but they didn't know how it was happening, right? And some people were asking me, well, why did they use GLM and not use GPT or the Anthropic models? And the reason for that is of the guardrails. That this is a really good example of them not understanding the semantics of things. So Hugging Face wasn't trying to hack anybody. Hugging Face was trying to understand how they were hacked. But because the AIs can't differentiate between having a red team cybersecurity analyst to help you figure out a breach versus an actual hacking operation, they couldn't get the guardrailed AIs to do the research, to do the investigation. So they had to use this is my understanding of this anyway, I could be wrong, but they basically had to use a non-safeguarded guardrailed system to get this figured out. And that's exactly what I mean, is that Hugging Face is not trying to do anything bad here. They were just trying to protect themselves. But because the AI doesn't understand the semantic difference of when you're looking into hacking events to try to protect yourself versus when you're looking into hacking events to hack someone, these are not the same. It just sees this under this blanket because it doesn't actually understand the semantics, and it's just putting in these kind of lazy guardrail things. That's kind of like a major problem. Or at least that's my strong conviction about this. Okay, let's see what else we got. I know I'm supposed to read this Aux Alpha, but you guys are keeping me super engaged with the comments. By the way, you guys are on fire today. I'm loving all of the awesome comments. Maybe we should just start doing live streams where it's like a free-for-all, and we just start meandering wherever the chat takes us. Okay. Biffit Chris is saying, does LLM have any other tool than language? Oh, I see. What I mean is biological life forms have lots of different kinds of chemical and physical signals it can use as inputs for contextualization learning. Yes, absolutely. So Chris, it does. Great question. And what that's generally known as is multimodality. So when you hear people talk about AI systems being multimodal, that's them describing that it's going to take different types of input of different modalities that will allow it to reason about things in far richer ways. So you'll get something that can look at pictures. You get things that can listen to audio. You get things that can process language. I don't know that there are systems yet that can smell. I don't know if you guys know about anything like that. But absolutely. So the multimodality stuff is really important. And I think that, I mean, it's really critical when you start getting into robotics, right? That is, oh, yeah, and this is another great one as far as the bubble bursting. But for robots to function effectively, they almost have to have a strong level of multimodality in the way that they're perceiving things, right? Because they need to be able to have visual sensors to understand like the physics around them. They need to understand the grip pressure, you know, like if they're shaking your hand, you know, so they need to have these kind of physical sensors. Sound can be really important to them. Being able to hear people talking to them as well as the like visual input. And another part that's really important for robotics is depth perception. So being able to reason about not just see things, but to be able to understand the depth of things. So that can be helpful in terms of them trying to grab something or walk downstairs. Now, for a lot of the language models, many of the language models principally focus just on textual information. But even with Claude, I don't know what your guys' experience is, but with my setup of Claude, I can... Okay. Sorry, what's happening? Dark Trap? GTT games? Oh, yeah. Yeah, when you get into sort of the recursive uh, self-evolution of the AIs, this is the part where things can get pretty wacky. Um, yeah, I have a lot to say about that. It it would take us really far down. Hey, Carbon. Yeah, man. Good to see you. Glad to have you here. Yeah, for sure. Um, sorry, what were we talking about? Oh, yeah, Tom's, yeah, I love that. Thanks, Tom. You're trying to keep me honest. This is decades of my bad training on saying 100x versus 100. Like I'm telling you, all the PhDs do this, okay? So blame my advisors. I hear what you're saying, though, and you're probably right. Uh, there's, oh, yeah, oh, so Claude. So I don't know if you guys do this with Claude, but I can have Claude analyze images. oftentimes I will take screenshots of things and I'll send the screenshots to Claude and say, Claude, process this and figure this out or something. And from that, it can do a bunch of interesting things. Yeah, I mostly, okay, so right now, yes, I'm principally using Claude. And my path through this is I try to not be married to a single AI. I try to look at all the different AIs as much as possible and see what I think they're good at, what they're bad at, this type of thing. And so I spent quite a bit of time playing with Gemini. And then I think maybe at the beginning of this year, I pivoted more toward Anthropic's Claude. And I principally use Opus. I think I started diving in really heavy with Opus 4.6, I think. Oh, sorry. Dark Trap saying Jizzle Fizzle is on the Discord is making and documenting her modest project with an AI agent inside a machine. I don't know how we say it. Okay, cool. And so what I use Opus for is, what do I use it for? So I use it for the entire VOD pipeline for GTT. So it helps me with all the edits. After I finish this live stream, I'll say, Claude, the live stream's finished, and do the VOD pipeline. And then what it'll do is it will go through, figure out the segments. It will start to generate the clips for me. Basically, a lot of the heavy lifting. It's super valuable. And I was using Opus Clips for that too, but I think I've gotten the VOD pipelining with Claude so nailed down that it's almost better now than Opus Clips. Yeah, and it did take about 6 months, I think, working on that to get it to that level. Yeah, Beach Ball, 100%. 100%. It's really interesting because when the AIs were first coming out, I really thought that Google was going to be dominating the space. I mean, look, they have all the infrastructure. They've got the ecosystem. They've got the browsers. They've got Android operating system. I mean, they're so strongly positioned to completely dominate in this space. It's kind of insane. Yeah, 100% Crip. It's kind of insane, the idea that Google wouldn't totally dominate the space. But what's happening, right? I mean, I think Anthropic's Opus line is leaps and bounds better than Gemini. And I think Google knows it too. Yeah, I agree with that. I think that's a very fair assessment, Cam Devs, is when you're that big and you have so much integration, you've got so many pieces, there's like so much work that you need to do to keep things kind of on track and keep things going. So they are going to go slower for sure. I still wouldn't rule Google out because of how much infrastructure that they have and how easy it'll be to work in their system, right? Like getting all the various pieces plugged together. So you know, it works with your Gmail and it works with your Google Drive and your calendar and all this stuff. It's just like fully integrated, very similar to the things that Apple can do. But as far as the AI technology itself, it seems as though Anthropic is, I think, in the driver's seat, at least right now. That's my take. What do you guys think? Should I create another poll for this? Let's create another poll for this. Okay. Poll. Which company is in the driver's seat for AI? Google, OpenAI, Anthropic, Moonshot, ZAI. We'll limit it to that. All right. Here's our new poll. All you guys got to do is just give. So the way the polls work again is to answer the most recent poll, you just have to say A1, A2, A3, A4, A5. And if you want to answer a prior poll, you have to specify the name of it. So if you want to answer this one, you have to say P4 space and then the thing. So, real curious what you guys think. Which company is in the driver's seat for AI? Google, OpenAI, Anthropic, Moonshot, ZAI. I'm going to leave this front and center. And I am going to take another quick bio break. Yeah. Yeah, your answers are very similar to the answers that I'd be giving. And for those of you that have been on the stream the whole time, guys, we're rocking out today. We're 2 hours and 22 minutes in. Oh shit, sorry. Sorry. Okay. Whoops. I messed it up. I don't think I'm supposed to add. Let's see. XAI. There we go. Sorry about that. Yes. So for those that aren't super initiated, awesome. Thanks for joining, Zach. Great having you, man. Yeah, super great chat today. Really love it, guys. We're really starting to lean in for our Saturday streams. So just to be clear for the uninitiated, ZAI and XAI are actually different companies. ZAI is out of China and XAI is Elon's thing. Awesome. Yeah. Yeah, stay logged in. It is good for the YouTube data. Yeah, and Grok is XAI. That's what we're talking about here. So Grok is A6. I don't know that I really spent that much time with Grok either. Okay. Is it? Okay, I'm going to take another short break. Let's start our little timer. 5 minutes. Stretch the legs. You can't vote? Digital? You've given too difficult. Yeah. It's too many answers in my poll. I'm sorry. Uh, Interesting. The front runners. This is kind of leaning a little bit the way that I would lean as well. I think I'd be very keen on Anthropic. Okay. Yeah, so let's take a quick bio, caffeine, all that stuff, and then let's keep going. Okay. Okay, guys. Whoops. Sorry about that. All right. Okay, so it looks like our front runners Wow, we've got a tie between Anthropic and Moonshot. That's pretty cool. I wasn't expecting that. I thought that Anthropic would absolutely come out ahead, if I'm being honest. But, Kimmy, right? Moonshot created Kimmy, right? Am I remembering that correctly? Awesome. We need to figure out a way to. Oh, you know what I can do? Guys, I can do this. It's going to be so awesome. And go over here, show the polls. Oh, I can't. They're not synchronized. The chat's synchronized, but the poll is not synchronized. Okay, look. I'll have the poll show up over here. And I'll just leave that there. And then we can have the chat over here as well. Dark Traps saying Honda is one of the most tuned and modified brand with BMW. So I guess AI just gets the data. What are we talking about? Love it. Yeah. Cyanogen, is this on YouTube? Yes, it absolutely is. So if you go to YouTube, youtube.com/@Goju Tech Talk, it should pop up for you. Let's actually go. Back over here. And all right, we're going to go back now and see what we get on this aux alpha. Okay, let's read a little bit more. I used to run Juan through Pinocchio, but it had lots of issues. Okay. Yeah. Oh, yeah. Oh, well, let's talk about this. Sorry, you guys keep saying really interesting things that stop me from reading this article. Hold on. This is a really awesome point that Dark's making. Video generation needs a lot of processing power. Okay. I've used a couple that have done video generation. vidIQ. I was using vidIQ, which is a sort of a social media platforming system. And they have their own AI system. And sometimes I just have it create like thumbnails. And in the process of trying to create some thumbnail, what it did is it actually created a video for me. And in that video, it took a long time to generate that video. And the video was complete and utter garbage. Now, I think that there's other systems that are doing video much better than this. Like, hey, Macchio, good to see you. What are you guys using for video generation, by the way? Doesn't OpenAI have something pretty good for this? I think the Google system has a pretty good video. Let's actually look this up together. This is an area that I'm not very well educated on. Video generation AI. Okay, we've got Runaway, OpenArt, Seedance. Oh yeah, Seedance. These guys. This is interesting. These guys keep hitting me up to accept them as a sponsor. But I think I've passed on them. Speaking of sponsors, there's a big thing that's happening this Monday. I'm not allowed to talk about it until Monday, but I'm going to do a special impromptu live stream on Monday, specifically for one of our sponsors to share this thing. So be on the lookout for a Monday live stream, and you'll get to hear some more about this. Okay, cool. So you guys are saying Google Flow, OpenAI, Google Gem? Google Gem for video generation? Oh, is it Gemma? Best video AI models. What's this? 11 labs. Huh. Okay, I don't want your marketing stuff. Google's video generation capabilities are driven by Gemini, Omni, and advanced VO video models integrated directly into the Google Gemini platform, allowing users to turn text prompts, images, or multimodal inputs into cinematic clips with synchronized audio. Cool. Text to video. Type a descriptive scene in the Google Gemini app and select create a video to produce short, high fidelity clips. Synchronized audio describes soundscapes like excellent. Google Flow. Yeah. Higfield. Okay, let's check this out. Higgsfield? Is this... I hate when they do this. This kind of, by the way, this kind of marketing trickery crap annoys me to no end. I think this should be like illegal. That you type in something like this, Higgsfield AI, and then Flova comes up as sponsored results saying that it's Higgsfield AI, but then really Higgsfield is here. Like, doesn't that feel like false advertising or something? Or it feels that way to me. I'm not like a super fan. Yeah, I haven't really used any of the video stuff, to be honest. I think that you guys will have to educate me on all of this. But I'll tell you, this does look pretty cool. This is one of those things where I think my speculation is the cost of doing these guys is probably really quite large. Simply because of just the volume of data that you have to create for this, right? Yeah, man. That's exactly. I feel like it's not right. No, I think that somehow it's passing through like Google's AdSense or sponsorship stuff, right? I don't think it should be allowed. Okay. So let's go back now to look at Ox Alpha. All right. I gotta lean back in my chair here. I'm super pumped that we're gonna make the 3 hour mark today, guys. We haven't made the 3 hour mark in a while. Were any of you on when we did the 10 hour stream? You guys remember that? I did one 10 hour stream. And let me tell you, I was about to lose my mind at the end of it. At some point, maybe when I'm in my new house, we will set up a day where we'll do a 10 hour marathon live stream. But I'm only going to do it if you guys do it with me, right? So we can all be out of our mind together. But I will tell you, it did start to get wacky toward the end. I think, okay, I know Cyber was there. Cyber, you still on? Cyber was there for sure. I think Colin was also there. And yeah, we were still, I think, pretty small when I did that. That was maybe 3 or 4 months ago. But I don't know. There's just to have a moment of realness. I think there's something cool that happens when you reach this sort of like true level of exhaustion. There's kind of like the realness of who you are starts to come out, because you can't really put on a show. And like, I try to be super authentic, but I think once I got into like hour 8 or 9, I was no filter. I think like all my filters, all my niceties, and trying to be careful to not say super bad things about people, CEOs, this type of thing. I think that all went sideways. So anyway, maybe a week or so before I start teaching at Stanford, I'll try to do one, because doing it while I'm teaching might be pretty tough. Yeah, exactly. Well, it'll be like that. It'll be a house party event. Uh, UK government tax authority is called HMRC, but if you type that, you get BS accountancy companies at the top. Interesting. Yeah. Okay. So back to Ox Alpha. OpenCode pushed it to developers as a free model for the next week. No lab name is attached. No founder is taking a victory lap. And you get a provider label, a set of technical limits, and a very large invitation to test it. That's enough. Free access with a 1,000,000 token context window is not a small trial for a coding model. Yeah, I mean, that's pretty serious. It lets you throw a real repository at the system, not some toy prompt, and see what actually breaks. Maybe your code base is messy, old tests, half documented services, refactors nobody wants to touch. Use it carefully while it lasts. OpenRouter's live model catalog lists Aux Alpha as a multimodal model that accepts text, images, and video. Interesting. Okay. With a million token context window and 131,000 token maximum completion. The same catalog shows prompt and completion pricing at 0. Okay. The same, what? The same catalog shows prompt and completion. Okay, I don't know what that means. Models Atlas, which tracks model listing, also shows Aux Alpha as released on August 20th, 2026, with the same stealth Aux Alpha identifier and free pricing. Those figures are real, the mystery is not. All right, the numbers are real, the leaderboard is not. OpenCode's announcement on X gave developers the pitch in plain terms. Aux Alpha is free for the next week. Multimodal, zero data retention, and has what OpenCode called generous rate limits with capacity for 100 trillion tokens per day. Okay, this has got to be fairly well funded for them to pull this off, because that is going to cost a lot of money. It's going to cost a lot of money. That is a big claim, but still an access claim. It does not tell you who trained the model, what data was used, or how it performs across a clean benchmark suite. That distinction matters. OpenRouter's own API entry for Aux Alpha does not show artificial analysis scores, a coding index, or the kind of independent benchmark block that appears beside some other models in the same catalog. Deep software engineering, one of the harder software engineering benchmarks, now watched by coding agent users, does not list Aux Alpha on the public bench SIFT leaderboard as of August 21st. The top public rows there are still occupied by named models such as Claude Opus 5 and GPT 5.6 Sol, with the best pass at 1 results in the low 70s. Okay. Still occupied by names such as... All right. So don't treat the current noise as a medal ceremony. That's treated as field testing. Developers always post screenshots when a new model surpasses them on a refactor, blah, blah, blah. Yeah, I got to be honest. I mean, I don't know. A lot of these... a lot of these benchmarks, I think, are not necessarily giving us a true representation of what the actual status is, because they can kind of game for that benchmark, right? And I don't know, it's hard to say, because if they train the system just so it does exceptionally well on that benchmarking suite, then that could be kind of like a false flag, is that it can have the appearance of being super incredible, but then in reality, it is just specifically very good for that benchmark suite. And when you use it for things outside of that benchmark, it's not very good. Like these kinds of things have been going on for things like the spec benchmark, spec 2000, spec 2020 or something, for a long time. And so I always take any of these benchmark results as a little with a grain of salt, I guess is what I'm saying. I think that they can still give you insightful things, but I just don't know that you can, like, really trust them, if that makes sense. Okay. I didn't see that OpenRouter got bought by Stripe. Interesting. Seems like insiders know the model behind it on X, but not able to say yet. I see. Yeah. I suspect there's probably some embargo restrictions. Like some people probably have been told what it is. Okay, so let's speculate here for a second, since we're getting some clues here that this Ox Alpha is so Ox Alpha is clearly like well-funded company model purely by the one piece of data that tells me this is very much a well-funded company is this part. 100 trillion tokens per day. So you've got to have, I think, a reasonable amount of money to have that many tokens supported. And the fact that they have a LLM that can support 1 million token context window. That implies basically that it's a very large LLM, and this implies that it's a company with deep pockets, simply because of the cloud expense. So given all of that, do you guys have any speculations on who? I mean, my knee jerk is that this is probably some well-established company that is running this, and it's not some like new startup that just kind of came out of nowhere. I mean, maybe, but I would speculate it's something like OpenAI, Anthropic, Google, XAI, ZAI, something like that. That's my speculation. What are you guys thinking? Do you think that that's... Do you have any intuitions? Digiter33 is saying Ox Alpha is Anthropic. Could be. There's one... Okay, now that's true. It could be like thinking machines. I mean, I'm not sure I believe that, but... And it could be that this is like a publicity stunt. So they want to show that it's going to come in and dominate all of these benchmarks. So then they can say that it dominated the benchmarks, and that evidence is there without knowing that we built it. And by the way, we're Google, right? Something like this. But the one thing I want to add is OpenAI has been talking about this secret model that they have that they refuse to disclose. Now, this is OpenAI, of course, and we know that it's not like you can really trust OpenAI more than, you can throw them. So it could be that this is OpenAI's secret thing, or it could be that OpenAI is just pretending like they have this secret thing and it's not. Mm. Vedran saying it's not Chinese. Oh, okay. Why do you think that, Vedran? It's not that I'm disagreeing with you. I'm just curious what kind of context clues you got. NM4K is saying that he or she thinks it is Chinese. OpenAI and Anthropic would be freaking out if that's the case. I mean, already just the Kinney K3 is sending people spiraling. No, yeah. So, Vedran, absolutely, I get that. But were there certain things about the way you used it that kind of gave you a hint about this? These companies were all up in arms against harnesses until recently. So it doesn't map up with releasing an open router, in my opinion. Okay. Cool take, Matt. ZAI is worth $75 billion. Like most of the company more than DeepSeek, it could be anybody. Zifu. Uh, Zifu is ZAI, right? Is that right? I can't type. Ah. Is that right? Okay, cool. Yeah. I learned so much from you guys. It's amazing how much knowledge about all the AI space we have collectively. I see. Okay. So Digiter is saying that the Aux alpha code design and visual design is very similar to how Anthropic designs, right? No. I think that's something really interesting that you guys are observing that I'm have been kind of finding myself, which is each of the companies kind of there's a it's hard to put into words, but it's like they have kind of like a feel about them, the way that they talk, the things that they struggle on, uh, the way that they kind of iterate, the way they generate pictures or code. It's like it's sort of like this unique tag related to them, and I absolutely agree. I think you can get some kind of hint about them from just like the just general interaction or interfacing. Cam Devs is saying if you one shot a UI with Claude, for example, it becomes very clear Claude made it. Mm-hmm. Yeah, 100% digit. Yeah, this is I got to be honest, I wasn't expecting that kind of characteristic would jump out, but I definitely think that it has. Like I know the way that Gemini behaves is very different than the way that Claude behaves. Yeah, Macchio, go cook some eggs. Go do it. Models inherently have their own UUID fingerprint in a way. Mm-hmm. Oh, for sure. Yeah. It right. If it had any kind of watermarking, then that would be a super clear signal. All right, so let's go back to this. Oh, yeah, sorry, there's one other thing I wanted to show you. And I just thought of it because of this comment about zero data retention. Okay? OpenCode's announcement on XGA developers, the pitch in plain terms, Ox Alpha is free for the next week, blah, 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 carries zero data retention. Okay, hold on to that for a second. Now, I was on Threads earlier, and I like this guy, Carnage for Life, and he's saying OpenAI and Anthropic have gone in different directions on safeguards to detect malicious usage of their models. Anthropic requires prompts and outputs to be retained for 30 days of analysis, while OpenAI will do pattern analysis without data retention. OpenAI has won this round. All right, I think this is actually very interesting. And I got to tell you, I do think that OpenAI has won this round, and I see it's really interesting because I can see arguments for both cases, but I'm very much for the zero data retention, which, probably all of you guys knew that that's the way I would lean. But zero data retention basically means that, for one, if they get hacked, then all of the interaction that you've had with their system, it's not going to be available for the hackers, right? That's really good. We want that. On the other hand, with having data retention, this is from Anthropic, it does allow Anthropic to do more investigation to people who might be doing malicious things. Now, the malicious things that I think Anthropic is probably concerned with is more model distillation than they're trying to use Anthropic or Claude to hack somebody's website. I think it's more just, are they trying to distill their model? But so I guess what I'm saying is I can see arguments on both sides, but I'm absolutely on Team OpenAI for this one. That I don't want the data retained for all of my prompts and interfaces with the AI model. And that feels like more privacy preserving. What do you guys think? Oh, awesome, Tom. Yeah. Yeah, the self-supervision stuff, learning from unlabeled data, I think is, in my mind, some of the most interesting stuff with AI. When you start to reason about the metadata and you start to do things like intuitions on the intent of something by looking at how the thing evolves over time, and that functions as a signal for metadata. But anyway, really curious to know what you guys think about this. I mean, I speculate that probably most of us are going to be pretty keen on what OpenAI is doing, that we probably want zero data retention. I mean, who kind of wants their data being retained? at the same time, it's so I absolutely disagree with doing the retention, but I can see the angle of what they're arguing. I can see how it's like, okay, uh, thanks, Dark. I can see the angle of like, well, it's going to make everybody safer if we do this. And in some sense, maybe it would, except if Anthropic continues to get hacked like they have been. And yeah, that's going to not be so helpful. Anyway, I thought that was really interesting. In I tend to side with Anthropic in just the grander scheme of a lot of things. Yeah, no doubt. OpenAI, I think, is looking for a whole bunch of C-suite people. Don't worry, I'm not Snowball's chance in hell would I ever bite on that. No way. Just the minimum bar for ethics is not present, unfortunately. Yeah, I mean, chem devs, as far as the guardrails making us safer, I mean, that's kind of, I think that's supposed to be the theory, is that with the guardrails, we will be safer. But I have to say that the execution of them, at least in today's form, they feel very, it's almost like they just restrict the capabilities. But I think that has more to do with the way that they're putting the guardrails in place. It's like really broad strokes or something, and then they become like artificially dumb, very restricted in what they can do. It feels like that's more of an implementation detail. Like this is like guardrail version 1 or something, and they don't know how to do it at all. So they're just sort of botching the AI systems. Uh, yeah, I don't think so. Yeah, and yeah, I think that they're beyond any prayer of a chance for me, man. Oh, so as far as the projects like that we'll be kicking off, so my plan is that we'll start actually investigating things like the GIA system in earnest in 2027, and a lot of what you guys can be helping with, I think, is once we have the general design figured out, then we can start to build up different aspects of the system. And we might be able to break those into small chunks, small pieces. And once they get carved off in those small pieces, we can probably get people to assist with those. The high level design of the system, I think, is, yeah, I for sure. This is my biggest problem with being CEO of Merly. I think that I need to be more in the open space world. I'm not sure exactly what I mean. It could be a bunch of stuff. It could be training data, it could be offloading compute for the training. It could be just kind of a bunch of different things that we look at. So I think right now it's more of a maybe getting the word out about GTT and sharing with your friends and getting us just more public support, simply because having like small amounts of monetary support for GTT to stay alive is going to be key. Like we don't need much money, but having things like their regular members or more people on the live stream, stuff like that, this all helps. as well as getting us just sort of more talent. And then we'll find interesting ways to kind of carve all this up. That's awesome. That's sweet, Dark. The guy right above you is also Greek. So, guys, we have broken the 3 hour mark, which is awesome. And I'm feeling like we might want to call it a day or call it a complete stream. I really am excited about the yes, it will be completely full open source. MIT or Apache or Berkeley license. Although I was thinking about maybe putting it under GPL just so we could stop big tech from being able to capitalize on it. But that kind of sucks, right? So I don't know, maybe we should have like a committee meeting about it and see what you guys think. I think the Linux stuff isn't Linux and Git under GPL? And didn't they do that on purpose to try to like stop the corporations from just having a free for all, but other people could use it for free? I can't actually quite remember. Hold on, let's look this up. Is Git, hold on. What license is Git under? Yeah, see, Git is under GPL. And that, I think, was to make sure that corporations had to essentially pay, but then average users could use it however they wanted. So I was thinking about that. I don't know. In the past, the things that I've open sourced, it's been pretty much all MIT and BSD. Yeah, for sure. Yeah, it'll be on GitHub. Yeah, that's a good point, Maciel. Yes. By the way, there's also this massive lawsuit coming out against Meta right now. You guys hear about this thing? It's like billions of dollars or something, going to potentially change the whole way social media works. Or like, I'm not totally sure exactly the details, but it keeps showing up in my feed that it's like the biggest lawsuit against Meta that's ever existed or something. It is tricky. Exactly. And it's very tricky. So, but the big thing with the geosystem is really to architect it so it has a deterministic component that we can continue to iteratively refine. And it won't be the be all end all, but it'll be generalizable. And by the way, we're going to, the first iteration is principally going to be for code, since, I mean, I'm kind of a code nerd, and I think many of you guys are as well. So that's going to be the primary target initially. Now you can use diff for other types, other domains, but somebody else can build those ones, right? They'll figure out how to do that once we start open sourcing this. And then we'll need to make sure that it has really good interfacing for SLMs, that there's a really good binding for the diff system to interface with the SLMs so that we can have this be local only. That's I think the primary goal of this. Local first, fully private, no cloud component. Cannot have that. That is like complete antithesis of the GS system. And already the diff approach works for that space. And then we'll also want the confidence aspect, that it has the confidence system, which will probably be something like a Bayesian network that essentially gives you a confidence score on all the inferences, which will give you an idea of like how much the AI actually believes in the thing that it's producing. And then it will just see where it goes from there, right? I think that as long as we have those foundational elements at the base, this will be, I think the thing that will be nice about this is it will set up so it can be extensible and for people to use on their own however they want. And it'll have the deterministic component, which is the main thing that's missing from almost all of the AIs that exist today. I mean, like, I know that those deterministic pieces are there, which is how they're able to get some kind of repeatability or logical correctness on things like code, but they're not like fully inclusive. They're just sort of pieces here and there. So how about peer-to-peer, decentralized private? That's interesting. Yeah. Yeah, I mean, that's an interesting idea. We should think on that. But a real thing is, I think we want the compute to stay really minimal, because I think we really want to have commodity AI. That's like one of the most important pieces, is that it's commoditized. Because with that smaller aspect of it, it allows for things like iterative refinement in a much stronger way than without it. Yeah, I kind of heard this about this MySpace thing. I wasn't sure if that was a joke or not. Okay. All right, guys. So, yeah, this was an awesome live. Thank you all for joining. And I'm going to be doing a lot of move stuff next week. I'm not sure if I'll be able to live stream next Saturday. I guess we'll just kind of play it by ear. But I may live stream on Monday to share an important thing from one of our sponsors that is pretty cool. So remember to join the Discord and join as a member for YouTube, and give us your 99 cents a month. It's helpful. And you don't get any ads on any of the live streams. That's a nice little bonus. And yeah, I think that's all we got for today, guys. So thanks so much for joining. And as always, keep going.